Enough with the theory. We are finally doing something technical. Knowing how to program is a very important skill to have. Thanks to it, we can write our own scripts that will exploit a vulnerability, automate some specific actions to make our life easier, or simply to read an already existing exploit, understanding it and being able to modify it according to your needs. There are two scripting languages to master. The first one, which is the easiest, is Bash scripting. Bash scripting is the system administrator's favorite tool. With it, you can automate tasks or even turn a complicated set of actions into a simple do-it-all script. It is a very easy language to master because it mostly consists of terminal commands. Let's write our first Bash script. The text editor we are going to use is NeoVim. There are many other editors out there, and while NeoVim can be considered confusing, I am going to hold your hand through the whole script. First, let's make sure that we have NeoVim installed with the which command. If it says NeoVim is not found, then we must install it. Remember that installing a software is an administrative task, so we must use our sudo privileges. Kali's package manager is apt, and most software has a manual included with it. If we run man apt, we can read apt's manual. In a manual, we have a list of possible operations we can perform with the software. We have update, upgrade, and install. Let's use the install function. We quit the manual by pressing the letter Q, as stated at the very bottom. And let's write sudo apt install NeoVim. It might ask with the prompt if we wish to really install it, and we should specify it with a Y that we approve the operation, and wait until completion. Once NeoVim is installed, we can simply write nvim and the name of the file we want to create. Let's say script and .sh to specify that this is a shell script. We are now inside a NeoVim prompt. NeoVim has multiple types of views. By default, we are in visual mode. We cannot write anything, but we can highlight some text with our mouse, for example. What we want is to enter insert mode. If we press the letter I on our keyboard, the word insert in full capital will be displayed, prompting us that we are now in insert mode and that we can write stuff. If for some reason you end up being stuck and cannot write anything, pressing escape will put you back into the default mode, and you will be able to get back into insert mode. Alright. Every Bash script starts with what we call a shebang, which are those two characters. And then /bin/bash. Then we press enter to get into a new line. Okay, what script do we want to write? One of the easiest scripts we can write is a ping sweep, which will send a ping command to every single IP address within our local network. If we receive an answer, it means that there is an up and running device that is using this address. Let's save our script. We will get back to it later. For now, we are going to perform tests within the terminal. In order to save a file within NeoVim, we must first get back to default mode. Let's press the escape key, and then let's press the colon symbol. You should see at the very bottom that the colon symbol is displayed. This area is the space where we write commands, and NeoVim interprets them. One of the commands that we can write into NeoVim is the command to save our file and to exit. The command for saving is the letter W for write, and the command for quitting is Q. We can write those commands separately, but to make our lives easier, we can simply write WQ and press enter. If we write ls, you can see that we indeed saved our file. In order to find out your local IP address, we have to write the command IP and then A for showing all interfaces. On my machine, my local IP address is 192.168.122.89, but your IP may be different. Let's grab that IP address and let's ping ourselves with the command ping and then our IP address. Let's add the C3 option to only show 3 responses, otherwise this will run indefinitely. We see that when a ping has succeeded, we have that line that says 64 bytes from and then the IP address. However, when a ping is not successful, we see that there is no response. There is no 64 bytes anywhere, so what we want are all lines stating that 64 bytes have been received. In order to retain all lines containing that 64 bytes message, we can append a command called grep that will search for every line containing 64 bytes. It works great, but to be honest, we don't care about the whole line. We just want a list of all IP addresses that are up and running. We're in luck. There's a tool called cut that does exactly what we need. Cut needs 2 parameters, the delimiter and the field. We are going to divide our lines by spaces. As such, we are going to use the D delimiter for specifying a space between brackets. Then we want to extract field 4, because field 1 is 64, field 2 is bytes, field 3 is from, and field 4 is our IP address. Okay, great, but the colon symbol is part of field 4. It's not too bad, we could leave it here. But that's actually a good excuse to show you yet another tool. TR is a tool that can be used to delete some specific characters. TR needs 1 parameter, which is a delimiter once again, and our delimiter is the colon symbol. Now we can run the command once again and everything works as intended. Let's select the whole command and put it into our script. Right now our script is great, but it's still not a ping script. We are just pinging ourselves, and we are doing it 3 times. Let's modify the count from 3 to 1, and let's iterate out pings in order to send a ping command to every single IP address within our network. In programming, loops allow you to repeat a specific set of instructions until a certain condition is being met. In our case, we want to loop our command until we ping the whole subnet from 1 to 254. As such, we create a variable called subnet, and then between the backticks, we precise that we should iterate from 1 to 254. And as long as this sequence is not completed, then we must perform the following action. At the very end of our ping command, we should add an ampersand, which will greatly improve our script speed by allowing multiple processes to run the same script at the same time without repeating the same IP addresses. If there was no ampersand, then we will have a single process that will ping every single IP address in sequence, which will take much longer. Now that our script is complete, let's try it out. Once again, let's escape insert mode, save and exit. Before starting the script, we have to make it executable by changing its mode with chmod. Let's write chmod plus x to add the executable flag to our file, and then the name of our file. Now to start our script, we simply have to write / and the name of our file. Our script works as intended. Now that you have been introduced to bash scripting, let's learn a bit of Python. Python is a wonderful tool to write prototypes and scripts while being very easy to learn. No wonder why Python is heavily used in ethical hacking. For example, if you need to exploit a vulnerability, most of the time, someone somewhere wrote a script and made it available for everyone to use, and it will most likely be written in Python. In your hacking career, you will see a lot of Python, and if you are unable to understand Python code, it might block you in your progress sometimes. What if you've got an exploit, but the vulnerability you are up against has something special that requires a slight code modification? You simply cannot afford not to know Python. So let's get right in. Every Python program must start with a shebang and /bin/python3 appended to it. Now let's learn Python syntax. Print allows us to write something to the screen. The thing we wish to print should be put between parentheses. If we wish to print a string, it will be between double quotes. Mathematical operations do not need to be inside a print statement. Those are just there to confirm that they work once the program is being run. To create a variable, we can simply name the variable and assign a value to it. Variables are very useful to store some information and reuse them afterwards. Strings are for what we call methods. We can apply different modifications to a string. For example, to put everything in uppercase, we can append a string variable with a .upper method, or we can calculate the length of a string with the len method. We can append multiple variables or multiple strings to a print statement, and everything will be printed one after the other. In order to assign a new value to a variable, the equal symbol must be used, meaning that if we write variable equal 3, in order to assign a new value to a variable, the equal symbol must be used, meaning that if we write variable equal 3, the amount of variable becomes 3. But if we wish to add 3 to the amount currently held by our variable, then we have to state that our variable is equal to the current amount of our variable, in other words, itself, plus 3. All of which can be simplified to variable plus equal 3. We can break down our program into multiple reusable bits called functions, which can make our code more readable while making things more concise by preventing us from rewriting the same bits of code everywhere in our project. Functions can be created with the def keyword and the name of our function. If there is nothing between the parentheses, then our function has no parameters. When we need to use our function somewhere in our program, we just need to write the name of our function with the parentheses. Boolean are a special type of variables. They can be either true or false and can be very helpful. If we imagine that we are writing a video game and we must check that our character is actually having an object in their hands, setting a boolean to on or off depending on if they are equipping something suddenly makes the check that much easier. Conditions are easy. We check that a specific variable meets a specific requirement with the keyword if. If we wish to make other checks, we can then append elifs, meaning else if. Otherwise, we will end our condition with else. In other words, if every other check fails, do the following. We can create lists in Python, and every item has a position in the list called an index. Every list starts with an index of 0, meaning that index 1 is actually the second item in a list. Tuples are the same thing. The only difference is that they are not variables. They cannot be changed, they are constant. Dictionaries allow you to pair values to a label. We call that a key-value system. Loops allow the iteration of sequences. A for loop is used to iterate over a sequence of items. A while loop is used to repeatedly execute a block of statements while a condition is true. When someone writes something complex or that can be useful to many, they often turn it into a module that others can then import into their own projects, with a simple import statement and the name of the module. One of those very useful modules is the socket module. Thanks to it, we can do some networking. We first initialize our socket and then we simply connect to our target. Now let's reuse everything we just learned. Create a port scanner. First, we want to iterate through ports, so we need a for loop. Then let's initialize our socket and set a default timeout of 1 second. Otherwise, we could wait for a very long time for a response. Then we acquire the connection result, and if the result is 0, it means that there is nothing to report. The connection is successful. So we print it out, close the connection, and go back into our loop. Our script is almost done, but there might be errors. We might want to quit the program, or the target might not respond. We have to take those potential interruptions into account. To do that, we must specify to our program that it must try to perform the set of actions we want, but there could be exceptions. We might want to suddenly stop our script with the Ctrl+C keybind. The hostname might not resolve, and the server might not be reachable. For all of those possibilities, print out the reason and exit our program. And that's it! Our Python program is complete. You have just learned 2 scripting languages. Now the keys are in your hands to expand your knowledge on both those languages and master them.